In 1959, some person, Arthur Samuel, happened to give the definition of machine learning. It's a field of study that gives computers the ability to learn without being explicitly programmed. So this is the definition that we gave in the starting. Okay, but in '98, Tom Michel comes up with another definition of machine learning. He says that well-posed learning problem. Okay, it is a well-posed learning problem means what? A computer program that is said to learn from experience with respect to some tasks. So some tasks specifically, we are just focusing on a particular task. Now this computer program is learning from experience and its performance P happens to increase with experience. Huh? If its performance on that particular task T happens to increase, the P is the performance. So P performance is increasing on this particular task T with experience E. So this is what is machine learning. Okay. So if you talk about, we just so what we are saying is machine learning is more focusing on algorithms. Okay, so more of algorithm than focus on data. So what exactly is an algorithm? An algorithm is a sequence of instructions that should be carried out to transform the input to output. So that is what is an algorithm, a sequence of instruction. Now there may be various algorithms to do the same thing. We want an algorithm which is more efficient, which would be using less of instruction, less of memory, maybe less of both. That is a more efficient algorithm. Now, some tasks, however, do not have an algorithm. कुछ टास्क होते हैं आपके पास पता नहीं है एल्गोरिदम क्या है, प्रोसेस क्या है. जैसे कि आप देखें कि आपको स्पैम टेस्ट करना है कि जो मेल आ रहा है वो स्पैम, तो आप कैसे टेस्ट करेंगे? कुछ तो एक तरीके होते हैं, आप बता सकते हैं कि अरे नहीं, अगर उसमें स्पैम में कुछ लिखा है कि भाई कोई चीप प्रोडक्ट्स हम बेच रहे हैं ना, तो एक कोई भी लोग कंपनीज आर जस्ट थ्रोइंग ऑन मेल्स टू पीपल एंड दे आर saying कि buy our product because our products are cheap, something like that. So what they have said कि अच्छा cheap word है मेल में, तो इसको स्पैम में प्लेस कर दो. और मे बी दे आर थॉट ऑफ सम अदर कैरेक्टरिस्टिक्स, स्पेलिंग मिस्टेक्स बहुत है, मतलब कि ये सही जगह से नहीं आ रहा है मेल, तो इसको स्पैम में प्लेस कर दो. दे हैव थॉट ओवर इट, बट व्हाट हैपेंस इज कई बार ऐसे रहता है कि यू मे वांट सर्टेन मेल्स, सो ओवर द टाइम what is a spam according to person A is not a spam according to person B. So it happens to change. How do we generalize it? So we want that the spam as per A should be well defined, which is not spam as per B. So we know what the output is. So what in case of this spam mail, what we do is, what is the input? Email जो का जो document आ रहा है वो input है. A email document that is having certain characters है ना in it is a input. Now we want to know whether this particular is a spam or not, right? So what is an output? Output would be yes or no. Yes, it is a spam or it is not a spam, isn't it? So we do not know how this transformation happens, how to transform an input to an output, what exactly went into it. जैसे मैंने एग्जांपल बताया कि हो सकता है कि दिस इज कुड बी अ केस कि एक चीप वर्ड लिखा हुआ है इसमें, तो हाँ ये सस्ते प्रोडक्ट के बारे में बात कर रहा है, तो इट इज अ प्रमोशनल काइंड ऑफ ए थिंग, पुट इट इन स्पैम. और देयर मे बी अदर थिंग, अदर वेज आल्सो. सो व्हाट कैन बी, सो ऐसे कई सारे एप्लीकेशंस होते हैं, यू डू नॉट नो व्हाई the output is yes or no, what really goes into, what is the algorithm behind it, you don't know exactly. So what can be considered spam happens to change in time from individual to individual, person to person. Spam is different. Okay, what we lack in knowledge, so what we do is, because we do not know how input is getting converted into output, so what we do is we are going to use the data that is already there. So a lot of data that is already there, we would be studying that. So we can easily compile thousands of example messages from which we know to be spam. तो कुछ spam messages हैं जैसे कि आपके पास आए, आपने उनको spam में place कर दिया या discard कर दिया, without reading you just discarded it. So uh, the system is able to learn, okay, this is spam according to you. And what we want to learn, so what are we doing? We are just, you can easily compile thousands of example messages, some of which we know to be spam, and what we want to learn, what constitutes spam from them. तो हम उसमें से देख रहे हैं कि क्या चीज कंस्टिट्यूट कर रही है स्पैम, तो द सिस्टम इज लर्निंग. In other words, we would like the computer or the machine to extract automatically the algorithm from this task. ऑटोमेटिकली पता करें कि भाई आप ए पर्सन के लिए क्या स्पैम है, बी पर्सन के लिए क्या स्पैम है. ओके, सो वी डू बिलीव दैट देयर इज अ प्रोसेस. Definitely there is a process that explains the data we observe, though we do not know the details of the process underlying the generation of data. How it is decided that this is a spam and this is not a spam, we do not know. But we do know कुछ तो process है, some process is there. Okay? जैसे कि साइकिल आप चला रहे हैं, आपको आती है साइकिल चलानी, एक व्यक्ति को नहीं आती है साइकिल चलानी. आप साइकिल चला लें, कितना भी उसको रूल्स बता दें, कितने भी थियोरी के लेक्चर्स बता दें, कितने भी वो वीडियोस देख ले, वो साइकिल चलाना कब सीखेगा? जब खुद चलाएगा साइकिल. क्योंकि आपके दिमाग में जो प्रोसेस है वो आप कोडिफाई नहीं कर पा रहे. You are not able to really, there is a process in which you have learned, but you are not able to really codify it and tell the other person ki okay, you have to keep your weight in the center and इस तरह से पेडल करना है आपको. कितना भी आप बता दें, वो हिट एंड ट्रायल से ही सीखने वाला है साइकिल चलाना. So this is more of an example of a reinforcement learning impact. Okay, so this is what we are just talking about, the spam mail, right? तो अगर चीप वर्ड लिखा हुआ है तो कह रहे हैं हाँ 80% तो ये स्पैम होगा. ओके, समथिंग लाइक स्पेलिंग मिस्टेक्स बहुत हैं तो हाँ 70% स्पैम मेल हो सकता है, या मिसिंग टाइटल ही मिसिंग है. तो ओवर द टाइम ना यू लर्न कि व्हाट आर द वेरियस कैरेक्टरिस्टिक्स दैट डिटरमाइन द ईमेल इज स्पैम. ओके, we do believe that there is a process that explains the data we observe. जिस तरह से हम ऑब्जर्व करेंगे डेटा को, कुछ तो प्रोसेस है, द वे इट इज गेटिंग कन्वर्टेड फ्रॉम इनपुट टू आउटपुट, though we do not know the details of the process underlying the generation of data. We may not be able to identify the process completely. Maybe we are not able to identify the process completely, but we believe we can construct a good and useful approximation. पूरा का पूरा प्रोसेस तो नहीं जान पाएंगे, मगर we believe that we can construct a good and useful approximation. We believe that though identifying the complete process may not be possible, हो सकता है पूरा का पूरा प्रोसेस नहीं आप जान पाएंगे, मगर still there is certain patterns, certain regularities, so that at least let's extract that some common patterns, some common regularities, and that is there is where machine learning is actually looking at. Application of machine learning methods to large database is what is data mining. So here in this book of Ethan, they are saying that yahi machine learning, when we are talking of large databases, we are saying data mining. It is an application of data mining. So there is an overlap between all of this. So here, do we call it data mining? So the book explains that you do mining of earth, na? Large volumes of data of earth you unravel and just take out the raw material to extract it. You mine it. What are you doing by mining? You're just bringing out something very precious outside, and that what precious is, what is the volume of that precious? It is very, very small, very, very small, depending upon the kind of earth you have really pulled out, isn't it? So you are actually digging a huge mountain to find a small kg of platinum or something like that. Okay. But machine learning is not just database problem. Only what you have to understand is data is more core on data mining. Right? A lot of data we are taking out and processing and all that. But machine learning is not just database problem. It is a part of artificial intelligence. To be intelligent, a system, what do you do? एक system, अगर हम कहें कि कोई चीज intelligent है, तो कब है वो intelligent? In a changing environment, it should have the ability to learn. With the changing environment, it should have the ability to learn. If the system can learn and adapt to such changes, the system designer need not foresee and provide solutions for all the possible situations. The system designer has not designed the program कि भाई आगे आने वाली जितनी भी इवेंचुअलिटीज हैं उसके लिए उन्होंने सिस्टम को डिजाइन करा है, सोचा नहीं आगे. क्यों? क्योंकि सिस्टम ही इस तरह से डिजाइन है मशीन लर्निंग का कि एज इट न्यू थिंग्स कमिंग अप, एज द एनवायरनमेंट कीप्स चेंजिंग, द प्रोग्राम इज गोइंग टू अडैप्ट एंड चेंज इटसेल्फ. So that is what is machine learning. So when we look at the definition of machine learning, It is saying that a computer program is said to learn from experience, E, with respect to some task T and some performance P. So there is some performance P. That this performance P should always keep increasing with each task that it does, or the task that it is doing, and with experience. वही टास्क पर जैसे जैसे उसका एक्सपीरियंस और आगे आगे बढ़ता रहता है, परफॉर्मेंस पी जो है वो इंक्रीज होता जाना चाहिए. So suppose your email program watches the mails you do or mark as mail as spam. तो आप क्या कर रहे हैं कि कुछ जो मेल्स आपके पास आ रहे हैं, कुछ मेल्स को आप स्पैम मार्क कर रहे हैं, किसी को आप रख रहे हैं, किसी को पढ़ रहे हैं, किसी को नहीं पढ़ रहे हैं. तो email, the program behind is just watching, and then it is learning. Okay, so what is the task here? What is the task over here? It is classifying the mails as spam or not spam, isn't it? That is the task that it is doing. So what is it doing? So this is a task. What is the experience that it is getting? Each and every email that is coming, and आप उसको spam या not spam कैसे भी जो भी mark कर रहे हैं, उसके हिसाब से experience it is learning. And कितने fraction of emails को सही classify कर पा रहा है, that is what is performance. What percentage of correct classification is being done? Okay, could be a performance measure. I hope you got it. So this is a new definition of machine learning. Machine learning. So you have a task, you have experience, and you have a performance measure. The same task over the experiences, the performance has to increase. Then we say that it is learning, isn't it? Okay. So what is machine learning? Machine learning is a study of algorithms that improve their performance on some specific tasks with experience. Okay, so you have task, you have experience, you have performance. It optimizes the performance criteria by using example data or past experience. What is the role of statistics here? So the statistics is a base theory, isn't it? Wherein what do you do in statistics? You take up sample from the population, you do certain apply certain formulas on that, t statistics or whatever, and then you are going to regression, correlation, whatever methods you apply, and you infer. You give a decision about a particular sample, about a particular population by studying that sample, isn't it? So you do inferencing, you do some inferences. So that is the role of statistics, and that is the underlying theory for machine learning also. And what is the role of computers over here? Computers are here developing. You are developing more, better, efficient algorithms to solve these problems, uh, so that it can accurately get better each time, isn't it? So you're developing a model each and every time, re-evaluating it with experience. The performance has to increase. So machine learning problem is not a problem. Suppose आपको कहना है calculate the payroll of the organization. Maybe 1,000 or 10,000 employees are there. I want to create a program for calculating the payroll. Is this a machine learning problem? This is not a machine learning problem, isn't it? There are certain specific rules by which the payroll is calculated. So definitely, this is not what is a machine learning problem. Machine learning is a programming wherein you do not have a lot of idea about the past and the future, in fact. So it optimizes the performance criteria using an example data or past experience. So कुछ example data है, कुछ past experience है. Accordingly, it is going to optimize the performance criteria. So something like human expertise, नेविगेशन ऑफ मार्स के लिए आपको जो भी ह्यूमन एक्सपर्टाइज अवेलेबल है पुराना, तो यू आर जस्ट स्टडिंग इट फॉर नेविगेटिंग ऑन द मार्स. और स्पीच रिकॉग्निशन or routing on the network, what is the best route the data has to move on the network, so it learns and accordingly moves out accordingly automatically. Okay, so these would be some machine learning areas, in fact. So learning general models from data for particular examples. So see, data is quite cheap, but knowledge is not. So a lot of data is there. You're going to study from the data, and something like a customer transaction is happening. So you want to study the customer behavior. Suppose people who are buying a particular book, then five other people bought this other book also. So एक something like ना, एक movie A देखी आपने, फिर B देखी, फिर E देखी. तो यू आर जस्ट फाइंडिंग आउट, अगर ए और बी एक कस्टमर देख रहा है मूवी तो डेफिनेटली वो ई का रिकमेंडेशन करेगा. ओके. So to build a model that is good and useful approximation of the data. So it is not exact, but a good approximation of the data. KDD process is a core to it. In fact, huh? The wherein when we just talk about KDD process, actually we are talking about data mining only. So KDD is a non-trivial process of identifying valid, novel, potential, useful, ultimately understandable patterns in data. Okay, so KDD लिख रहे हैं, actually KDD, any data that is coming, you got to clean and all, process it and all of it. But when we talk about machine learning, we're not really focusing on the pre-processing or the processing of the data. We are more focusing on algorithm. So these are some applications of KDD. So we can just move on with this. So what we see as growth of machine learning is, what are the trends? You can see that day and day we are having better algorithms that are coming up. Improved data capturing is happening. Uh, the error in capturing of data is less. Earlier humans were there putting in data. Now you do not. You just have the device, but there could be errors. So still it is an improvement in the data capture. Networking capabilities have improved, so data is moving very fast around, isn't it? Computers has also become fast. Processing powers have become better. Moreover, software itself has become so complex to write by hand. So you want the software to improve by themselves. A lot of sensors, IO devices are there which are capturing the data for you. So a huge amount of data is available for you. And they are capturing it more accurately than before. So you can see a lot of application of machine learning in the times to come. Demand for self customization of users. So you just don't have on the person to just look at the customer behavior and accordingly send an ad to the person. Okay, so automatic self customization, seeing the environment you want to be done. It turns out to be difficult to extract knowledge from human experts. So suppose in an organization you have a sales manager, how he was really doing so good. Hmm? And once he moves to another organization, he takes all the knowledge with himself. And how much ever you tell him, you have to teach the other people how to really do this sales. It's not easy. Certain things are very easy to teach other people. Certain things you just cannot teach the other person. So it's very difficult to, in fact, extract knowledge from a human expert, how much ever he is willing to also. Okay. So these are some areas wherein machine learning is being used: speech recognition, natural language processing, computer vision, medical outcome analysis, robotic control, and computational biology. If you look at, we have these supervised, unsupervised learning, and reinforcement learning. So, and you have artificial intelligence, from where a part of artificial intelligence program can be classified as machine learning. From machine learning programs, some can be supervised learning, some can be unsupervised learning, and some of them can be classified as reinforcement learning. So when you have classification, regression, or clustering can come in supervised learning. If you already know the classes of that particular cluster, then it becomes supervised learning. But if you do not know the classes, then the clustering becomes the unsupervised learning.